A lot of traffic.
Yeah, they should have put the coffee in the back of the rooms.
They should have. And that door is not going to stay shut, and it's going to be loud. So I'm just going to kind of hang out there.
That's
for a
fine.
little bit.
That's fine. Well, folks could come in and grab a seat. There, Rick. Then he left. If you guys aren't going to be too disrupted by people coming in and out for the next few minutes. That's the problem of an 8 o'clock presentation. Well, I think we're going to try to get started here on time. We have a lot to try and cover. Beginning of day 2 of a terrific workshop. We're going to be starting to get into more of the specific tools and approaches over the next number of sessions in this room. And we are going to be assisted by Susan Heyman, who's at the door this morning, with Enviro Issues as we get to the discussion and the dialogue part of this session and the rest of the sessions here. Susan's going to be helping to facilitate this session. But to begin with, we are going to hear from Pam Repp and Todd Lickfett with the U.S. Fish and Wildlife Service talking about the Landscape Scale Energy Action Plan. As a brief introduction, Pam's been involved in landscape scale planning efforts for more than 28 years with the Forest Service and with the Fish and Wildlife Service. In particular, Pam was involved in implementing the Northwest Forest Plan, Everglades Restoration Plan, and is now Region 6 Division Chief for Wildlife, Energy, and Climate. And she'll tell you more about the Landscape Scale Energy Action Plan with Todd, who is also a member of the team and the technical and planning committees. Todd's a relative newcomer to the Fish and Wildlife Service, but has over 10 years of experience using GIS for conservation planning and resource management with the Park Service, the Forest Service, and the Department of the Defense. So please join me in welcoming Pam.
Microphone? Yes. Okay, I need the neck to be recorded. How's that work? Okay. Well, good morning. I'm glad all of you are here. So we'll take you. And we're very excited to be sharing with you a project we've been working on called LEAP, Landscape Scale Energy Action Plan. And before I get started, though, I want to introduce a couple of the team members, just in case you have technical questions about LEAP. There's a lot of moving parts. So Tara would be the person you would want to talk to in regards to ECOS and IPAC, and you'll learn what these terms mean in just a moment. Jim is our data steward and science-based guru. And Tim Kern back here from USGS is our partner who developed science-based for LEAP for us. And then you'll hear from Todd in a moment. Also, I want to say that we have a newsletter. The newsletter is sitting on that corner chair over there. And on the back of the newsletter is some information about how you can contact us. So if you get excited about LEAP, grab one of these and give any of us a call. So for those of you that are not from this region or from this area, the Mountain Prairie region of the Fish and Wildlife Service covers 8 states, and depending on how you count it, 6 major LCCs, so there's a lot of overlap. And the significance of our region is that we have a tremendous amount of energy resources in the region. This graph simply shows the wind resource energy that's available in our region. Anything in color is either fair to superb from an energy potential standpoint, and the energy developers know about this map. This is a chart that simply shows our workload, the Fish and Wildlife Service's workload associated with this increasing energy demand and development. So from 2007 to 2010, you can see that our workload simply associated with wind energy has increased fairly dramatically. In addition, this is a graph showing between 2000 and 2009 the number of oil and gas wells that are in production, and they've almost doubled between 2000 and 2009 to approximately a little over 70,000 active oil and gas wells. As you all know, as you've been listening to the politicians on the radio and TV, renewable energy and energy production, domestic production is a high priority for everybody. And we anticipate that this energy demand is going to continue to increase over time. So the energy demand is there, the workload is there. We wanted to devise a tool, a process, a set of tools to help our fish and wildlife biologists in the planning of these projects, as well as to help the developer. So that's how LEAP came to be. And there are two overriding goals for LEAP. First is, because of this energy demand, because of this development, we want to make sure that we have the tools to help facilitate the siting of these energy projects in a way that benefits conservation, has a lesser impact on the environment. So we want to provide information early to the project planners so they can help in their siting and business decisions. The second goal is to help our field biologists. They have to write the biological opinions and the NEPA documents, et cetera. So we want to give them state-of-the-art tools, up-to-date data to help them in their analyses, because we have the same number of biologists as we did 5, 10 years ago, yet the work is going up. So we need to help them in an efficient manner. And all of this within the context of the landscape scale. And as you folks associated with the LCCs know how important that is. So these are the two main goals for LEAP. And we're very excited about this. And I think that this has a lot of different applications. It doesn't have to be restricted to energy development. It can be any form of development. And I'm very excited to be presenting this to the LCCs in the event that you see a place for this in the work that you're doing in your conservation planning at a landscape scale. So those are the goals of LEAP. That's the history of LEAP. That's why we're doing LEAP. And now I'm going to turn it over to Todd Lickfett. He's our GIS landscape ecologist, and he's going to go into more of the scientific and technical details of LEAP that are the tools that may be of interest to you. So, Todd?
All right, so Pam told us the story of how LEAP came to be, and I'm going to take the next 20 or 30 minutes to describe what LEAP actually is. So the Landscape Scale Energy Action Plan is not really a plan per se, but would be better described as a suite of tools, data, and analysis that has been developed in our region with the intention of facilitating more proactive landscape scale conservation planning. We are piloting the LEAP project in the state of Wyoming with the target date set initially for the end of this fiscal year. So we have a pretty short window here in which to work. After that pilot is completed, we're going to look at what worked, what didn't work, and hopefully be able to expand LEAP out into the other states in our region and possibly beyond that. LEAP will not be all things for everybody, but we have been looking specifically at the needs of developers and the needs of our own biologists. But we do think that things we are working on will be useful to a much broader range of organizations as well. Part of the reason we think we'll be able to accomplish that pilot within this relatively short window is we are leveraging two existing online systems to provide access to the products we're developing as part of LEAP. Those two systems are the ECOS IPAC Initial Project Scoping Tool, which will be used to provide site-specific information primarily to developers or project proponents. The second system is the USGS Science Base, which we'll be using as a spatial data repository. So the first of those two systems, the ECOS IPAC system, will be used to provide information on sensitive resources or conservation elements in LEAP lingo found within the vicinity of a proposed project site. This system is online and currently functional, but LEAP is working to augment the information being provided by the system. Some of the questions that the initial project scoping tool could help a developer answer include where to site projects to minimize impacts and their regulatory burden. And that will be done through a landscape scale vulnerability assessment, which is a spatial analysis that the LEAP team is in the process of developing, and I'll talk about that a little bit more momentarily. This tool will also help answer the question which conservation elements or trust resources are likely to be affected by that project footprint and its activities, and how to avoid, minimize, or mitigate impacts to those conservation elements. Additionally, it will help answer what policy should be considered by the project proponent. Relevant policies that we'll be providing information on and links to include the Endangered Species Act, MBTA, BGIPA, and the recently finalized land-based wind energy guidelines. And one important aspect of the initial project scoping tool is that we hope this can be a way to provide a link or a pathway to all the other tools that other organizations are developing or have already developed, so that when the time is right, they can find additional information that may not be provided through our own system, or information that's coming from a different perspective than that presented by the Fish and Wildlife Service. So as I mentioned, the landscape scale vulnerability assessment is a specific analysis we're working on that will be provided to developers through the IPAC tool. LVAs, as defined by LEAP, are a spatially explicit analysis that rank the landscape based on relative vulnerability in terms of exposure and sensitivity of conservation elements to specific types of development. So in a nutshell, what this analysis will do is it will provide a visual summary of sensitive resources and species on the landscape. It's intended to guide site selection away from sensitive high-value areas and to areas of relatively lower conservation value. So best case scenario, we think the developers could use this information as one factor to consider among many others when they're choosing sites for development. Worst case scenario, if they've already purchased land or already have a site in mind, it at least puts them on the same page as us in knowing the relative amount of conservation conflict they're likely to have at a particular location. From another perspective, the LVA, rather than trying to avoid high-value areas, in the case of developers, could be used by conservation planners to actually select high-value areas for additional protection or conservation purposes. And just as a caveat, this sort of analysis is at a landscape scale, it's fairly coarse, and so it is intended for use in preliminary site selection and will not be appropriate for micrositing within a project site. In terms of the pilot project that we're currently working on, as I mentioned, it will be for the state of Wyoming with a completion targeted in end of September of this year. Within that LVA, we're looking at a number of different conservation elements which we've identified. Primarily are what we consider traditional trust resources such as threatened and endangered species and migratory birds. But we're also trying to be fairly holistic in our approach and including other species of concern such as bats, which we know are impacted by wind energy development particularly. Because LEAP is focused on energy development, the types of development that will be considered in terms of sensitivity will include oil and gas development, wind energy development, and energy transmission, though the processes we're developing for this initial pilot LVA could be expanded to include other development types, as well as other species that we might not get to in this first iteration. We've contracted with University of Redlands in California and NatureServe to assist us in developing a LVA modeling framework. And whenever practical and possible, we are going to be leveraging existing conceptual and computational models to incorporate into that LVA. We recently started soliciting knowledge from expert panelists to inform both that overall modeling framework and models for the specific conservation elements within the LVA and to rank the relative sensitivity to those development types. And that group of experts includes not just people within the service, but personnel from a number of other organizations and stakeholder groups. And this process is intended to be fully transparent and repeatable. So all the decisions we make, all of the geoprocessing involved with this model will be fully documented. And in addition to making the data available, we plan to make all those geoprocessing models and any tools we develop available to the public as well. All right, so I've got a few slides showing a not quite live demo of the ECOS IPAC initial project scoping tool as it exists today, and then I'll show a mock-up of some of the functionality we hope to add in. So the user is prompted to input their project area, which right now they can do by selecting a state and county from a drop-down list, or by drawing a project area as a polygon or as a line. And in the near future, they'll be able to actually upload a shapefile with a more discrete definition of their project area. They also select their project type in very general terms, so oil or gas, mining, power generation, et cetera. In the future, we may ask for some additional information here on what specific sub-activities they will be doing as part of their general project type, so that we can provide more detailed results in the information we provide. So after they provide that information to us, we give a list of endangered species Act species based on intersection of their project site with species ranges as specified by our field offices. This is all current functionality. And this is a mock-up of some of the things that LEAP will be adding, the most obvious of which is this information provided by the vulnerability assessment. So we know there's going to be a lot of spatial variation in terms of element distribution within a given project area. So we'll be providing some sort of summary statistic or chart giving them a general idea of the overall vulnerability or overall conservation value of their proposed project site. We'll also provide a report that gives detailed information on the data underlying this composite layer so that this analysis isn't just a black box, but they can have some understanding of what resources or what information is resulting in the values you see here. Additionally, they'll be able to toggle some of those additional data layers in the map viewer to provide context to their site, and we'll provide links to access the source data in the science-based data repository, which I'll get to momentarily. So in addition to that spatial information, which we'll be adding in, the IPAC team is working on developing conservation measure reports, which will be provided to the project proponent. And they'll be filtered by both the project type and the project location specified by the user so that they're getting a filtered list of results rather than just a long laundry list of conservation measures, which are essentially best management practices, which if implemented could help avoid, minimize, or mitigate impacts to conservation elements. Yes, sir?
You know, if we could maybe hold questions to the dialogue afterwards and let Todd get through the presentation, I think that might help. Additional functionality that IPAC is working on, and this isn't necessarily a LEAP function, is the ability to report back to our biologists through the IPAC system whether or not those conservation measures have actually been implemented so that our biologists can enable adaptive management. All right, so that's a quick overview of the IPAC system as it is today and as we envision it being a short time from now. Now I will cover the science-based system, which, as I mentioned earlier, we'll be using as a
primarily for data management and data sharing. So ScienceBase is a USGS system. It's web-based, and in the context of LEAP, we are using it for data information management. It can do a lot more than that, and I encourage you to stick around for the next session in which Tim Kern will be giving a slightly more detailed overview of ScienceBase. So for LEAP, we'll be using it as a data repository in a virtual catalog. The data repository will be used to archive completed pilot LVAs and all the raw and derived spatial data associated with those, along with geoprocessing tools or scripts and documentation of the process. That data will be available via download or web services, with the exception being some data which is sensitive and is essentially being given to us on loan. In that case, whenever possible, we will provide links to the originator of the data so that if you can't get it from us, you can contact the data owner and get it from them. We'll also have a virtual catalog, which will enable users to search and browse the data, both within our data repository and other external data sources. And the intention is that we can provide links to other conservation and energy-related data that maybe isn't being used in the LVA, but could provide additional use to both our biologists and other people using this system. We've also identified the need to look at future scenario models to have a better understanding of what's going to be happening on the landscape in the near future. And so when possible and when available, we'll be providing links to development scenario models. In Wyoming, we know Nature Conservancy and other groups have developed some really good ones, and some models for different climate change scenarios. Again, some screenshots from the ScienceBase interface. This is a secure system, so while the general public can access files based on the level of permission set, either on a file or folder basis, for a lot of the data we have, because it is of a sensitive nature, we will require authentication for access. I should also mention Pam introduced Jim Lindstrom, who's serving as our data steward for the LEAP pilot area. This will be a managed database, so there will be some layer of quality assurance, quality control for the data that's located in here. And we're trying to avoid it becoming just a dumping ground where bad data goes to die. This picture shows a record for a spatial data file, in this case, Wyoming toad predicted habitat, which is on loan to us from the Wyoming Natural Diversity Database. ScienceBase has a lot of functions that we like. You can store detailed metadata with each record, and a record could represent a single file or a collection of files. You can add tags to your records to make searching for the data much easier. And you can include your records as part of a LEAP or a ScienceBase community, which is the foundation for that idea of a virtual catalog. So data that we add can be included in other organizations' virtual catalogs with a ScienceBase, or data that they upload into the system. If we simply tag it as a member of the LEAP community, it becomes part of our virtual catalog so that we can search for it within our own catalog. And you can also set relationships between different files. Then, of course, you can download the file or access it in several different formats or web services. Again, that will be based on permission set by the data steward. Within ScienceBase, you can find data either by browsing in a folder structure or by category or topic, or you can search using kind of a traditional text-based search, or with a geographic search where you outline a bounding box and then the system returns files within that designated area. And you can actually set a footprint for non-spatial files so that this geographic search will return shape files or spatial data and non-spatial files which have been tagged with a footprint within the search area. How are we doing for time? Great. Great. So to kind of summarize, I wanted to present some ways that I think LEAP has synergy with the mission of the LCCs. The most obvious of which is we are trying to link strategic landscape scale planning to on-the-ground conservation delivery. In the case of LEAP, we're doing this by providing a landscape scale view to project proponents through the initial project scoping tool. And we're also trying to take a very collaborative approach to the development of the models, particularly the LVA, in that we're both leveraging existing models and we're including a lot of different groups in the model development process. So while the final model will represent the services perspective on the world, it is being informed by many different groups. This diagram is a model that's being worked on by the Wyoming Natural Diversity Database and the Nature Conservancy of Wyoming, showing migration concentrations for raptors. They're doing several other migration concentration models for different bird guilds. And this is an example of the type of information that's being developed by other groups that we think we can provide added value to by incorporating into our LEAP process and by providing additional ways to get this information out to the public in a proactive way. Similarly, we're attempting to the greatest extent possible to provide open access to our spatial data and to any geoprocessing tools we use. And a couple ways that LEAP, I think, could actually be useful to the LCCs are that during this LVA development process, we're probably going to identify a lot of data gaps that exist, and we think the LCCs could play a very fundamental role in helping develop those basic data sets, spatial data at a landscape scale. And finally, while we are trying to address primarily energy development with LEAP, we do see that this process could be applied to many other types of development or just landscape change in general. So climate change or other drivers of landscape change could be incorporated into the overall modeling process. So with that, I do want to acknowledge a lot of the groups that have been working with us, and if I've forgotten your particular organization, I apologize. These groups have been involved in a wide range of capacities, everything from sharing data to working on developing specific conservation measures, or just providing input on the overall process or serving on expert panels. And I left a spot up here for any other groups that we haven't had a chance to reach out to yet. We're here to reach out to you, and we would love to hear your input, suggestions, criticisms, anything we can do to make what we're working on more useful to the public, to developers, to biologists in general. And I think we do have a little bit of time for questions.
This is perfect. I'd also like Susan to come up and help facilitate this. Try and capture the thoughts, the ideas, suggestions. That's part of what this workshop is all about. And we have about 15 minutes for this because we have one more presentation in this session. So with that, Susan, how would you like to kick this off? We've had a couple of questions early on. I want to make sure we give you an opportunity to ask that first. So.
Why don't we get those, and then I'm just going to record if there are some, Melissa will be taking notes of the key discussion points, so I'll just be capturing if there's some specific suggestions. So please don't be dismayed if you don't see Yeah, could you just do a quick summary, a synthesis of that?
Sure. The question was, how will LEAP attempt to address cumulative impacts of large-scale, particularly oil and gas developments that have occurred and are occurring and will continue to occur on the landscape? Cumulative impacts is something we're struggling with and looking at good ways to address. With respect to fragmentation, that is something we are considering as one factor that's going to go into the landscape scale vulnerability assessment. And I didn't really have time to go into a lot of detail on what exactly we're looking at and evaluating in that, and I apologize for that. So we will attempt to address fragmentation in that, but I agree in general that sort of cumulative impact is something I think we're still struggling with. Pam?
We know that's a critical issue, and I think we're handling it several different ways. One is through the evaluation by the individual resources, the species we're going to be addressing. Fragmentation is going to be a big part of that, and it's going to be ranked by the expert panels. And so you will see fragmentation as kind of creating a hot spot, and our conservation measures trying to address that. But also the landscape scale vulnerability assessment is going to highlight those large areas, those large intact areas. And so we're not going to want to be putting projects that cause fragmentation in those areas if at all possible. So we're trying to address it at multiple scales from a project siting, project impact perspective. In terms of cumulative effects, that's one of our goals with LEAP, is to develop the tools where we can calculate that and measure that over time. We're not going to have that by September, but that's one of our goals because we also know that's exceptionally important. But I think LEAP was going to be able to highlight, to display visually those areas that are currently contiguous, and then when you see a project put in the middle of that, how that's going to kind of fracture that. So I think visually it's going to help us. We'll be able to, the biologists are going to be able to quantify it, but our real goal is try to keep those large areas intact. So we're hoping that having that information, we can help site these projects to avoid that, to put them in already fragmented, disturbed habitats versus the intact habitats. So if you have additional ideas, this is from our region perspective and from a development perspective, this is one of the biggest issues.
Well, from a standpoint of just going out and interacting with the BLM or with even the oil and gas companies or wind energy companies or solar energy companies, it is mostly a focus on a specific site. And that could be 5,000 acres or it could be 50,000 acres. But the fact is, if you don't deal with the fragmentation, it just sort of creeps up on you in a way that, you got a little polygon up there that said your plan here, and you just lead people down the path that all we have to do is plan for this area and hope that we do the right things. If you keep fragmenting these areas all over the place, it has to be over large landscapes. Otherwise, it isn't a very good tool.
Right, and we realize our field biologists have a tremendous workload, and try as they might, they don't necessarily have the time to look at the whole landscape when they're evaluating impacts of a specific project. So that's what we're trying to provide through this tool.
And we do need to get to some other
Okay,
questions.
this is important though, can I answer this question real quick? So one of the values of LEAP is, Todd talked about this monitoring coming back into the system. LEAP will, every time a project is actually going to be implemented on the ground, that project will be incorporated into the landscape scale vulnerability assessment and rerun in essence. So it'll be a real-time view on the landscape. So you will see that next project, and you'll see over time how that's changing the landscape. So that's one way we'll be at least visually being able to track it at a landscape scale level.
Sir? Hi.
Yeah, Todd and Pam, just a couple quick questions. Maybe the first one, maybe I missed it, but do you integrate across vulnerability assessments for multiple species and come up with just a single vulnerability assessment, or do you do multiple vulnerability assessments for each species? Because some are going to be very sensitive, many aren't going to be sensitive at all. How do you weight that? That's the first question. And then the second question is, how do you factor in climate change? I mean, the landscape's going to be changing over the next 50, 100 years, so what we see now
Well, to answer the first question, the assessments will incorporate multiple species. So a single assessment will essentially be a composite layer representing many different species as weighted by their sensitivity or significance in terms of a particular development type, or if you want to think about it in terms of the stressors caused by the activities associated with a development type. And right now we're trying to decide whether this is going to be an analysis that's static and run ahead of time and provided through IPAC, or whether it's going to be more of an intelligent system where the user will input very specific sub-activities that are going to be performing possibly conservation measures which could avoid or minimize the impacts of those activities, and then provide a real-time assessment back to them based on what's left over after you've minimized and mitigated the impacts of those activities they've identified. So does that answer the first question? Okay. Second question, another tough one. We've identified climate change as you all have, as something critical to think about, but for the pilot, we simply don't have the time or the resources to bite that off. But it is definitely on our radar for next steps. Do you have anything additional to add to that? Yep, the BLM RIAs are an example of one of those additional landscape scale assessments that's being done by a different agency, but they have very similar mission, very similar interest to us, and so to the extent we can leverage what they've already done, we're going to do that.
I'm curious as to how energy developers themselves are involved in your process. How are you incorporating their perspectives?
The question was, how are we actually incorporating developers into the process? We just recently, last week, 2 weeks ago, had a workshop where we were soliciting input from our potential end users, which included biologists from our agency and others, and from developers and other stakeholder groups. So we did get some useful feedback from them on how this might be useful, things we were thinking about that maybe weren't going to be so useful to them, and we're trying to make our tool to fit their needs and the needs of our own people.
Talk a lot in LEAP about the vulnerability assessments related to conservation, largely ecological conservation. How does LEAP respond to vulnerability of communities and shifts in human communities? Sorry, I realize I've got a lot of human communities. And shifts in both population growth of communities, expansion, that kind of stuff. Is that getting somehow wrapped into the vulnerability assessment as well?
Well, the current iteration will look at the landscape as it exists today. But again, some of the data I identified as potentially being included in the virtual catalog that we'd like to weave into the assessment eventually would be predictions of human, urban and residential development, other energy development, so that you can overlay that as an additional layer on the landscape to consider.
That would be something that is both responding to shifts in climate, but also being a driver that in many ways is right up there with shifts in climate.
Good point. Pam, any other? Anything? Okay. I think the gentleman.
Oh, do you have it?
Well, I think the gentleman back here had a question a while ago. Maybe not. Okay. Yes, sir.
This is the last question.
The question, if I could summarize, is who is going to be providing the knowledge and the logic behind the actual model? Is that correct?
Well, it's not only that. If you want to use this in a particular project, let's say you've got a big energy development going in southeast Utah, so you want to go down and work with Fish and Wildlife and BLM, maybe the Park Service and local ranching groups, somebody's going to have to go down with a tool and stand up in front of the audience and explain what it does and help people run through it and probably discuss some parameters and interpretation of the output. And, you know, in order for a project to be really, you know, if we're dealing with real on-the-ground problems, they're usually complicated and have a lot of personalities involved. I mean, you know the routine, a bunch of meetings and going out and drinking beer with people and explaining things. And it's a fair amount of time. And these things that we're dealing with here are fundamentally complicated. And, you know, talking about connectivity and climate change and groundwater impacts and different species responses, these are big, complicated issues. They're not easily described in a 30-minute talk. And just to make this really effective and to help people on the ground, I think it's going to take ongoing, pretty substantial and sustained human support of the decision support system. And that's a problem we're dealing with in some of our programs too. So I'm just wondering if you've come up with some great enlightenment that will help us figure out how to solve that. Have you got there yet?
Obviously, we're facing that, and that's one of the reasons I was so excited about being here today. And I have to step out of my comfort zone by creating the newsletter and things like that. We actually don't have a budget for LEAP. We've been running on the graces of people like Tara and Jim and Todd and Tim from USGS on giving us their time because I think they believe in this. But we are starting to we got a little bit of money from Larry. Thank you, Larry, to help us out. And one of the things that we're doing, and my supervisor, the assistant regional director, is doing, is trying to get the word out on the value of this and trying to gain some support and momentum. We do envision over time that there will be permanent positions assigned to making sure LEAP is successful. Right now we're not there, but it is on our regional director's performance for this year. So there is interest, and I think what we need to do is continue to reach out, create the tools, get those tools out there so that the project proponents can start using them. And I think it's going to come naturally with time, but it does take a lot of effort. Yep. Thank you.
And let's thank Todd and Pam. That was a terrific presentation. And I assume you guys are going to be here all day. I know there were questions we were unable to get to. I encourage you to talk to Todd and Pam and the rest of their team throughout the day if you get a chance. We have one more presentation in this session, and that's from Erica Rowland. Erica is a conservation scientist working on climate change issues in the North American program of the Wildlife Conservation Society. She's been studying vegetation dynamics and their interaction with changing climate for several years. Erica's work of the last few years has been focused on climate change adaptation using planning framework developed by the Wildlife Conservation Society and others to assess management actions in the face of climate change. Obviously what we're here talking about this week. Welcome, Erica.
So first of all, I want to thank Mike very much for squeezing me into the end of this session. I know the agenda was pretty full, and it's great to have the opportunity to speak about this. And I also just want to say up front that I'm not going to be speaking about a specific application of a scenario planning approach in a specific setting. I'm going to be speaking more generally about a project in which we're engaged for the LCC network. So just a little bit of background about this project. Obviously, we're all here, or at least a great many of us are thinking about the uncertainty in association with the potential impacts of climate change on natural systems. There's been some sense that scenario planning is one tool that might be really good to apply to this uncertainty. There's some familiarity with a few approaches, but in general, there's a limited understanding about this particular tool. So we've been working with several folks to kind of explore the breadth of approaches and try to find out where they might fit best in the toolbox of dealing with uncertainty. So the specific objectives of this project are generally to facilitate the understanding about scenario planning approaches, identify through various means approaches that fit managers' and planners' needs, identify the skill sets needed to develop and apply scenarios in an effective manner, and then ultimately provide training. And what we've been doing to date to accomplish this is doing a lot of reviewing of scenario planning approaches, both in the peer-reviewed literature, but also from a whole lot of other sources, including talking extensively with experts engaged in these efforts. We've been conducting needs assessments to try to get a sense of the kind of decision-making context and the range of types of decisions and the kinds of information that folks use in their planning and decision-making processes. And we've been doing this by hosting focus groups, listening sessions, and probably going to use a tool like surveys as well at some point. And then ultimately we look towards hosting either a webinar series or a workshop, bringing together experts who have been working in these approaches and also some of the managers and end users, potential end users. We're going to be developing a guidebook along the lines of, for those of you who are familiar with the vulnerability assessment guidebook, in terms of the depth of treatment of different topics, and then ultimately roll out some trainings based on this. Who's involved with this? There's a collaborative kind of lead team, myself and my colleague Molly Cross from the Wildlife Conservation Society, working with Kurt Johnson from the National LCC office, and then Donna Brewer and Michelle Haynes from the National Conservation Training Center. And then also participants from the USGS, Rick Soja and Kathy Irvin from the Northern Rockies Science Center. And then finally, most importantly, a growing group, actually, of experts and end users who have experience with scenario planning approaches, and then also kind of the outputs of the process and how they've been able to use them. And so all of these folks are help guiding the scope and nature of the project and the resulting products. So this guidebook and this training is going to be dealing with the why and how of scenario planning, or at least that's how we've been discussing it to date. And there's going to be a relatively, we're not quite sure what the emphasis on each of these components is going to be, and we're hoping that some of our needs assessment work will help inform this. And so next I'm just going to step through some basics about scenario planning, and I apologize for those of you who are fairly familiar with the process. I was anticipating a mixed crowd, so just tackling these one at a time. First of all, what are scenarios? Multiple plausible futures. So, starting at the present and looking to different ways in which the future would unfold. And some of the characteristics of this, and this is hardly a comprehensive list, include that the multiple nature of these futures represent the key uncertainties of the drivers in relationships, both internal and external to the system. Through the process of developing scenarios, there's an explicit treatment of the assumptions underlying these drivers and system relationships. And then finally, to varying degrees, they integrate qualitative and quantitative information in the process from a variety of sources. Obviously, science is a key source, but also technical expertise, stakeholders, and other community and regional partners. And an important thing to remember about this is scenarios are not intended to be predictions or forecasts with associated probabilities or confidence intervals. It's really an exploration of the potential outcomes or the potential futures. In the context of planning, there again, it's just using these scenarios, multiple scenarios, and planning for a variety of possible futures. So using scenarios developed through a structured process, and there are many structured processes out there involved with decision making, and then there's some key steps in the scenario planning process. The scenarios are developed to address very specific issues or questions of importance, to explore the potential impacts of a range of futures. On one or a set of targets, there's a lot of customization, I guess, that can be employed in scenario planning to help make decisions. I mean, they don't necessarily, scenario planning is not going to make the decisions for you. The approach is going to help inform these decisions. Why might you consider scenario planning? Well, it's really suitable I wouldn't say specific, but more suitable or less suitable in certain situations. And one of the things we're trying to accomplish through this guide is identifying those situations. I'm sure some of you are familiar with this graphic and the lower part of the page, looking at complexity and uncertainty. I mean, those are kind of the key characteristics of the situations in which it's best suited. Complex systems, those that have multiple dimensions or multiple variables, likely acting across different scales, and very difficult to predict. And then irreducible uncertainty can be from a number of different sources, and not all uncertainty is irreducible. There are many ways of dealing with uncertainty in decision making. But some of the uncertainties that are pretty tricky have to do with human behaviors in particular. I'm sure many of you are familiar with the scenarios that were developed for the fourth assessment, the IPCC, which were narratives, qualitative narratives based on thoughts about future population, economies, the development of technology and adoption of that, land use. So those human dimensions of decision making come into play. Controllability, I've heard people have been talking about non-stationarity. It's a pretty common topic in the context of climate change. The rate and magnitude of change sometimes makes our confidence in the effectiveness of decisions we might make uncertain, given that rate and magnitude of change. And then finally, another thing to consider is the time frame in which your decision needs to be made in. In some cases, there are uncertainties that if you had, 5, 10 years, you could address in some very scientific, using more scientific methods that help to reduce the uncertainty. But you're faced with this decision in the immediate future, and so you have to just deal with it, essentially. And then another perspective on why you might consider scenario planning is thinking about what you might get out of it. There's 3 broad categories of outcomes that you can pull out of scenario planning. A lot of the efforts that we've reviewed to date have had the most success with outcomes in the understanding category, sort of raising the awareness for the need for adaptation, considering impacts and their associated vulnerabilities on important targets, and also examining climate interactions with other stressors and drivers in the system. For planning, exploring potential futures can help you consider what kind of future you want to move toward in a more proactive sense. Obviously, developing response options is a key part of planning. And then scenario planning is and a lot of people have raised this point, a real good way to engage stakeholders in the process, which also goes back to the understanding component. And this is an incomplete list of the potential outcomes, just to give you a sense. And then finally, deciding and implementing. Obviously, moving towards implementation and actions on the ground is everybody's ultimate goal. But the actual process of scenario planning and engaging with others and the kinds of information you bring in could help identify some effective ways of implementing the options upon which you decide. And then also even think about actions that might improve stakeholders. If you're talking about something that's more effective, if it's implemented across the landscape, thinking about how stakeholders, you can improve their capability to implement. And then finally, how do I do scenario planning? Well, there's 3 broad phases, and there's multiple steps within each of these phases, and in many cases, there are iterative cycles within each of these phases, depending on how the process unfolds. But basically, there's a preparation phase, scenario building and refining, using scenarios, planning and then implementing those actions. And then many would argue that scenario planning, or using a scenario planning approach, is not kind of a one-off process, that you have to anticipate revisiting this process because it's kind of built into the way you approach your decision making. So just to flesh these out a little bit, in the preparation phase, you're really finally scoping the issue in question, thinking about the spatial and temporal scales of the systems and the drivers, thinking about your planning cycles, your decision cycles and the time frames in which you need to make these decisions, defining your anticipated outcomes. You need to go into any planning process, I guess, with your eyes wide open, depending on the resources you have and what you can anticipate as outcomes, as you step through. Starting to identify key drivers and gathering information. And so with these quantitative and qualitative inputs, you move into this scenario building and refining phase. So that starts out with developing multiple scenario narratives. And then once you have these, and these narratives are often qualitative storylines, although they're infused with a great deal of quantitative and scientific information. And once you have that, here's a major decision point in the process. You can either step right through and use those qualitative scenarios as a filter to evaluate the potential impacts on your target, or you can go through take a different pathway to that and invoke computational modeling. stimulating your scenarios in a geospatial way, and then moving into impacts models, using the output from those scenario simulations. From there, you're going to develop, assess, and organize response options, so you might come up with an entire laundry list. But the real key is prioritizing those and deciding which of those actions, in terms of moving into the using step, which of those actions might make sense in the current time, but also anticipating future decision points and the actions that you might take as the future unfolds. And this is why you might need to revisit the scenario process. If you've anticipated some future decision points and you're kind of tracking, how the trajectory of the future since you began your process, then you will likely need to revisit this. These next series of slides, and I see Mike's just stood up, so I'm going to pick up the pace here. It's just highlighting some of the approaches that we've encountered in our work to date, and maybe just building off a little bit of the few of the differences in how folks have gone about doing the scenario planning. So this is a very large-scale project, the 35 countries of the European Union, and what they're doing is they're developing alternative policy scenarios and trying to anticipate the future risks to biodiversity based on these. They're looking out at 2050, and it's involving 250 scientists from a variety of institutions and organizations. And they're using both, they're starting out with their qualitative scenarios based on these policies, alternative policies for multiple sectors from energy, economy, climate, and then going through the process of quantitative simulation models and impact models. Next, at a little bit of a smaller spatial scale, and some of you are probably familiar with this project that took place in southern Florida. And here they're looking at trajectories of future landscape transformation and the potential implications for conservation and various targets in this landscape. They looked at several different time slices, and this was a process that involved stakeholders and experts. Again, they started out with scenario narratives, and that was the stakeholder process, participatory process, but then stepped off into simulation and impact models based on the outcomes. And here you can see from the maps here, they actually looked at what they consider the 4 key uncertainties in their landscape affecting conservation. And then finally, at a finer scale, and although this isn't specifically a conservation example, it is an example of where a group addressed some very explicit questions about human behavior and their tolerance for using municipal effluent in water supplies and different costs that would be associated with that. So I bring this one to your attention just because they are addressing very specific questions. It's at a finer time scale. They did both near-term and long-term planning. And then the participation, it was an internal process, internal to the Tucson Water Department, although they have communicated since then their results to the community for whom this affects. It was a very qualitative focus, but a great deal of quantitative inputs, as you can imagine, in a water issue. And they had some very concrete outcomes, these timelines with actions that they were going to take in the near term, and then very, very explicitly identified decision points. And just to bring to your attention, this is an organization that finished their plan in 2004, and they've already revisited the scenario planning process because they've reached some of these anticipated decision points and kind of spiral off from there. So this was just an attempt to give you kind of a sense of the range of scenario planning efforts. This is, again, hardly comprehensive, but just some examples. And then finally, just where we're going next in our project. Tomorrow we're having a listening session here, and this is part of our needs assessment component of our project. It's actually going to be in this very room at 9 a.m. to 11 a.m., so you have some time. Please feel free to drop by, because we're really looking for input on how this guide will evolve. We may follow this up with an online survey to the broader community for those who can't make it tomorrow morning. Continuing to review evaluation approaches. We're hoping that the guidebook will be out in the training start in the fall of 2012. And then finally, if you're involved in a scenario planning effort or you have some experience as an end user, we're looking for both perspectives, so please feel free to contact me at any time. Thank you.
Thank you. We don't have time for questions. We have to stay on time with the concurrent sessions. But Erica, you did an awesome job of getting an hour's worth of information in 15 minutes. And I encourage any of you who have questions about scenario planning or the workshop to see Donna, Brewer, or Erica anytime during the day. And we'll start in here again in about 8 or 9 minutes. So please come back. Thank you.
Thanks, Mike.